Comparing equations and inequalities. This is mostly about inequalities, but we'll start with the equations for a basis of comparison. And here is that first equation, 3x equals negative 15. Equations with a linear term and only one variable or unknown have one correct answer. In this case, the answer is x equals negative 5. We graph this answer on a number line with a single point. Let's do a similar problem, but make it an inequality by changing the equal sign to a greater than symbol. So we have 3x is greater than negative 15. The process of solving is very much the same as for an equation. We divide both sides of the equation, well, in this case the inequality, by 3 and bring down the answer with the symbol. Now here's where the difference between equations and inequalities starts. Instead of the solution being a point, the number, in this case negative 5, becomes not a point but a boundary point. There are two different types of boundary points. The solid boundary point applies to the greater than or equal to symbol and the less than or equal to symbol. And the greater than or less than symbols have their boundary point represented by an open circle, meaning that although the point is the boundary point, the point itself is not part of the solution set. In this case, which of these boundary points applies? Since the greater than sign means an open circle for a point, we use this for our boundary point. And here is that boundary point graphed on the number line. Now what does it mean when we say this is a boundary point? The boundary of what? It's the boundary between the solutions and the non-solutions. One side of the point contains all the solutions. The other side of the boundary point contains no solutions. We need to use the inequality symbol to determine which side of the boundary point is, on which side of the boundary point the solutions are found. In this case we have the greater than sign, meaning that the solutions are found to the greater than or right side of the boundary point, which we represent by drawing an arrow to the right of the boundary point. What direction do you draw the arrow? When you have the unknown on the left, look at the symbol as the tip of the arrow. Whatever the direction of the arrow on the symbol, that's the direction of the arrow from the point or the open circle that you will draw. Let's look at another inequality. 6n minus 6 is less than or equal to 22. To find the boundary point, we solve for n. We need to first move the negative 6 over to the right side, and negative 6 becomes positive 6 on the right side. We combine like terms and it becomes 28 on the right. Now to finish, we divide both sides by 4, so n is less than or equal to 7. Now to graph it, we look at the direction of the symbol and whether it will be a point or an open circle. And this is the one that matches. So we put the point, or the boundary point, at 7 and draw the arrow to the left. The arrow to the left means that it goes all the way to negative infinity. Now here's another one. 2x plus 6 is less than negative 2. Stop the video, see if you can solve for the unknown, then graph it on a number line. Then restart it to see if you got it right. Okay, for the first step, we take the positive 6 to the other side, and now we have minus 2 minus 6 on the right, and the 6 on the left is gone. We combine like terms, so the right side is negative 8. We divide both sides by 2, and we have x equals, or is rather less than, negative 4. Which graph fits with the less than symbol? Well, it's the open circle with the leftward arrow. And here it is graphed. Now here's another one. What are we going to do with it? Notice that the variables on the right side of the inequality, to get it in a familiar form, we need to turn it around. But when we swap sides and turn it around, we need to turn around the inequality sign too. So this becomes 7y is less than or equal to 28. We solve it by dividing by 7, so y is less than or equal to 4. And we match the graphing method with the inequality symbol. And here it is graphed. We have the solid point at y equals 4, and then the arrow to the left. Here's another one. This is 25 minus 5x is greater than 40. We'll remove the symbol chart this time and see if we remember how to do it. First step, we move the 25 to the right of the equal sign. And on the other side, the 25 becomes negative 25. We combine like terms on the right, so 40 minus 25 make 15. To solve for x, we need to divide both sides by negative 5, so the right side is negative 3. But is that right? No, it's not. Anytime we divide by a negative number in an inequality, that changes the direction of the inequality symbol. The greater than symbol becomes less than. So we've switched it around. Now we can graph it. Now less than, what kind of boundary point is that? Well, it's an open circle. And here we have it at negative 3. And the inequality symbol pointing to the left, which symbol is that? Well, it's the left arrow. Now, here's another inequality. Negative 2n plus 6 is less than 24. Stop the video, solve for the unknown n by finding the boundary point, then graph it on a number line. Restart the video to see how you did. Okay, to solve, first we move the positive 6 over to the right. It becomes minus 6 on the right side. Combining like terms, 24 minus 6 make 18. Now we divide both sides by negative 2 and switch the inequality symbol, since we divided by a negative number, so the less than symbol is switched to greater than. So n is greater than negative 9. To graph it, we use the open circle for greater than and draw the arrow to the right. So let's summarize. We've covered a lot with this video. We solve the inequality just like we would an equation. If we have to divide by a negative number to solve, we need to change the direction of that symbol. We need to remember that less than or greater than is graphed as a small open circle. We need to draw the arrow in the correct direction, which would be the same as the symbol. This has been Comparing Equations and Inequalities. Thanks for viewing.